If you take a sheet of paper and then glue its ends together in this parallel sort of manner, you get a cylinder. But if you take that same sheet and then glue its two ends together in the opposite manner, you get a Mobius band. But what's really going on here? In topology, a quotient space is when we take our topological space X and we mod out a sort of relation. Consider the unit interval of real numbers from 0 to 1, and really it just looks like this line segment with a length of 1. Now imagine if we took this unit interval and tried to glue together its right and left ends. As we do so, it becomes more and more clear that when we take the unit interval and perform this gluing, we get a circle, or at least something that's going to work exactly like a circle. So how we would write this process is by taking our space 0 to 1 and then modding out this relation. This relation is that 0 and 1 have the same equivalence class. We can then say that this new glued space is homeomorphic to the unit circle S1. As you could imagine, this is one way that we can write out a cylinder. I'll just take my circle, which is 0 to 1, mod out that 0 and 1 relation, and I'm just going to cross it with 0 to 1. What this does is take a square and take its left and right edges and glue them together, getting us this cylinder. And something else we can do is mod out that same relation from the first unit interval. This product will give us exactly a torus because we took the two caps of this cylinder and we connected them the same way we did the left and right ends of this square. And before I forget, we just wrote down that 0 to 1 mod out 0 and 1 is homeomorphic to S1. Therefore, this product is going to be homeomorphic to S1 cross S1, meaning that the torus is really just a product of two circles. Now say we want to write out a Mobius band this way. All we'll do is take the interval 0 to 1 and cross it with -1 to 1 when we mod out this specific relation that I could write out more precisely, but all it really is we'll take the left edge of the square and we'll map it oppositely to the right edge of the square. So the bottom left point would go to the top right point and so on. And so via this notation, this is how we write taking a sheet of paper and then gluing its ends with a twist to get our classic Mobius band. So you may be wondering now, what would happen if I took this circle, and instead of crossing it with another circle, I crossed it with the same component we used to get the Mobius band, meaning we would take this cylinder here, and instead of gluing it at the edges, we would glue it oppositely oriented at the edges, which would require going inside. Well, you get a Klein bottle. Thanks so much for watching, and have a nice day.